Hello friends, welcome to your own channel Online Physics. Here we will provide you solutions of your problems. And here we will also explain the various concepts of physics. So subscribe this channel to getting more videos on physics. In this video we are going to discuss previous questions of contour integration, which is the most important topic for CSIR NET. And in the previous video we have already discussed all questions from 2011 to 2013. Link for that video available in the description. And now in this video we are going to discuss all questions from 2014 to 2017. So these both videos cover all the concepts related to contour integration. So you should watch both videos. It will surely help you in the exam. So let's start. So now the first question of this video is from June 2014. The question is, if C is the contour defined by z equal to 1 upon 2, the value of the integral dz upon sine square z is. Now let's see how to solve this question. Now here the function is fz equal to 1 upon sine square z. Now in the contour integration, the idea will be same. The value of integration will be equal to 2 pi iota sum of residues. So first we have to calculate the value of residue at the pole which is under the contour. So let's find out the pole, which is sine square z equal to 0. So this is sine square, so the pole is of order 2. Now here z will equal to n pi. Now in the question we have the condition that z is equal to 1 upon 2. So that means the value which is greater than 1 upon 2 will not exist in the contour. And here we have n equal to 0, 1 and 2, so on. Now here you can see that for n equal to 1, the value of z becomes greater than 1 upon 2. So that will not exist under the contour. So here we have n equal to 0 which is under the contour. So that means z will equal to 0. Now here fz can be expanded into Laurent series about z equal to 0. So here fz is equal to 1 upon sine square z, which can be expanded as 1 upon z minus z cube upon 3 factorial plus z5 upon 5 factorial minus so on square. Now further it can be write as 1 upon z square 1 minus z square upon 3 factorial plus z4 upon 5 factorial minus so on square, which will become 1 upon z square 1 minus z square upon 3 factorial plus z4 upon 5 factorial minus so on minus 2. Now in the case of Laurent series, the residue of fz will equal to coefficient of 1 upon z in the Laurent series. Now this can be written as 1 upon z square 1 plus 2 z square upon 3 factorial minus z4 upon 5 factorial plus so on plus 3 z square upon 3 factorial minus z4 upon 5 factorial plus so on. Now in this series you can see that there is no n term of 1 upon z. So that means the coefficient of 1 upon z will become 0. So it means the residue of fz is equal to 0, and the value of integration is 2 pi iota sum of residue. So it will also becomes 0. So that means 0 is the right answer. Now the next question is from December 2014. The question is the principal value of the integral sin 2x upon x cube dx. So the solution of this question is, now the given integral is minus infinite to plus infinite sin 2x upon x cube dx, which can be written as imaginary part of integration minus infinite to plus infinite exponential iota 2x upon x cube dx. Now here, if you remember that in the previous video we have cos term in the integration, which we write as real part of the exponential term. So for sine it will imaginary part. Now the function we will get fz is equal to e iota 2z upon z cube. Now the pole for this case is z equal to 0, which is of order 3. So now the value of integral will equal to pi iota residue of fz at z equal to 0. Here we take only pi iota because we take only the imaginary part. Now it can be solved as pi iota 1 upon 3 minus 1 factorial double derivative of z minus 0 cube exponential iota 2z upon z cube at z equal to 0, and it will become pi iota 1 upon 2 4 iota square exponential iota 2z at z equal to 0. Now after solving this we will get minus 2 pi iota. Now here you can see that we have to take only imaginary part. So here the imaginary part of this function is minus 2 pi, which is the required answer. Now the next question is from June 2015. The question is the value of the integral dx upon 1 plus x4 is. Now let's see how to solve this question. Here the function is 1 upon 1 plus z4. So first find the poles, which can be found out by putting 1 plus z power 4 equal to 0, which is z power 4 equal to minus 1, and this can be written as exponential iota 2n plus 1 pi, and here n is equal to 0, 1, 2, so on. So z will equal to exponential iota 2n plus 1 pi upon 4. Now after putting the values of n, we will get z equal to exponential iota pi upon 4, exponential iota 3 pi upon 4, exponential iota 5 pi upon 4, and exponential iota 7 pi upon 4. Now let's say this is the contour, imaginary axis, this is real axis, plus r minus r. Now here you can see that pi upon 4 and 3 pi upon 4 will exist in the upper part of the contour, and 5 pi upon 4 and 7 pi upon 4 will exist in the lower part. So that will not exist under the contour. So here out of these all values we have z equal to exponential iota pi upon 4 and exponential iota 3 pi upon 4. only that values lies on the upper half of complex plane. So that's mean we have to find out the residue at these 2 points. Now for these type of functions, the residue of fz at z equal to 0 will equal to pz upon q dash z. Now we have the function fz equal to 1 upon 1 plus z force. So from this function we have pz equal to 1 and q dash z equal to 4z cube. So now residue of f at z equal to exponential iota pi upon 4 1 upon 4z cube, which is equal to 1 upon 4 exponential iota 3 pi upon 4. Now the next is residue of f at z equal to exponential iota 3 pi upon 4, which will become 1 upon 4 exponential iota 9 pi upon 4. Now the I is equal to 2 pi iota sum of residue, which can be written as 2 pi iota 1 upon 4 take as common 1 upon exponential iota 3 pi upon 4 plus 1 upon exponential iota 9 pi upon 4, which can be written as pi iota upon 2 cos 3 pi upon 4 minus iota sin 3 pi upon 4 plus cos 9 pi upon 4 minus iota sin 9 pi upon 4, which will become pi iota upon 2 minus 1 upon under root 2 minus iota 1 upon under root 2 plus 1 upon under root 2 and minus iota 1 upon under root 2. Now after simplification we will get pi upon under root 2. So now here I equal to pi upon under root 2 is the right answer. Now the next question is from June 2016. The question is the value of the contour integral 1 upon 2 pi iota integral exponential 4z minus 1 upon cos hyperbolic z minus 2 sin hyperbolic z dz around the unit circle C traversed in the anti-clockwise direction is. Now you can see that this question seems to be difficult, but now you will see that how the systematic approach make it easy. So let's start to solve this question. Now here the function is fz equal to exponential 4z minus 1 upon cos hyperbolic z minus 2 sin hyperbolic z, and this constant term 1 upon 2 pi iota we will take it later. Now write this cos hyperbolic and sin hyperbolic in exponential form. That will become e4z minus 1 upon ez plus e minus z upon 2 minus 2 ez minus e minus z upon 2. These two will cancel each other and we will get e4z minus 1 upon minus e minus z upon 2 plus 3 upon 2 e minus z, and this will become 2 ez e4z minus 1 upon 3 minus e2z. Now let's find the pole. For pole at z equal to z0 we have 3 minus exponential 2 z0 up equal to 0, which will become exponential 2 z0 equal to 3, then we will get z naught equal to natural log 3 upon 2. Now the next step is find the residue at z naught. Now residue of f at z equal to z naught will equal to pz naught upon q dash z naught. Now this function can further write it as 2 exponential 5z minus exponential z upon 3 minus exponential 2z. So from this pz naught will become 2 exponential 5z naught minus exponential z naught, and q dash z naught is the differentiation of this term. So we will get q dash z naught is equal to minus 2 exponential 2 z naught. Now residue of f at z equal to z naught can be written as 2 exponential 5z naught minus exponential z naught upon minus 2 exponential 2 z naught at z equal to z naught, and these two will cancel and we will get exponential 5z naught minus exponential z naught upon minus exponential 2 z naught at z equal to z naught. Now put the value of z naught, we will get minus exponential 5 natural log 3 upon 2 minus exponential log 3 upon 2 upon exponential 2 log 3 upon 2. Now this will become minus under root 3 power 5 minus under root 3 upon 3. Further it will become minus 9 under root 3 minus under root 3 upon 3. So it will become minus 8 upon under root 3. Now the value of integral will become 1 upon 2 pi iota sum of residue. Now this 1 upon 2 pi iota is coming from the given integral. So it becomes 1 upon 2 pi iota residue is minus 8 upon under root 3. So this will cancel and you will get minus 8 upon under root 3. This is the value of integral. That is the right answer. Now the last question is from June 2017. The question is the integral of z exponential iota pi z upon 2 z square minus 1 dz along the closed contour shown in the figure is. This is the figure. So let's solve this question. Now here the function is z exponential iota pi z upon 2 upon z square minus 1. So first we have to find the poles, which can be found by z square minus 1 equal to 0. So this becomes z square is equal to 1, which will equal to plus minus 1. Now here you can see that both these values plus minus 1 is under the contour. Now let's find out the residue at these points. Now the first residue of f at z equal to 1 is equal to z minus 1 z exponential iota pi z upon 2 upon z square minus 1, and it will equal to z exponential iota pi z upon 2 upon z plus 1 at z equal to 1. Now by putting the value of z we will get exponential iota pi upon 2 upon 2. The next is
residue of f at z equal to minus 1. This will equal to z plus 1 z exponential iota pi z upon 2 upon z square minus 1. This can be written as z exponential iota pi z upon 2 upon z minus 1 at z equal to minus 1. So now it becomes exponential minus iota pi upon 2 upon 2. Now the value of integral is 2 pi iota sum of residues, which can be written as 2 pi iota exponential iota pi upon 2 plus exponential minus iota pi upon 2 upon 2. So now here we will get 2 pi iota cos pi by 2. Now we all know that cos pi upon 2 is equal to 0. So the whole term will equal to 0. That means the value of integral will equal to 0. So this is the right answer.
So thanks for watching. Subscribe for learning and share for helping. Share this video to all your friends so they will also get the benefit from this. And last thing, please don't forget to like this video. Thank you.